All right. We got to go through this review. See how we do. So I think you guys are set in about a second here in normal CDF on the calculators. 6.3, sample distribution review. This is review 1. Explain why you cannot use the methods in this section for the following situations. It's believed that 5% of jelly beans are colored red. You sample 70 jelly beans and calculate how many red you get. Why can't you use it?
It's less than 10.
Less than 10? Okay.
Jelly beans is not 10% of the population.
Okay. 70 is not 10% of the population like that. We actually have no idea how many jelly beans are over there, right? So I like it. That's all correct stuff to say. The average weight of football players is 210 pounds with a standard deviation of 15 pounds. What is the probability that a random sample of 3 players will weigh more than 190 pounds? What do you got? What equals 0? It equals 0? Why does that equal 0? What's that? Okay, let's see. The average weight of a football player is 210 pounds with a standard deviation of 15 pounds. What is the probability of a random sample of 3 players? I just think that random sample of 3 players is that's too small of a thing to collect on. It'd be going you, and you, and submit it to the world. So I don't think your sample size is big enough, nor do you know how many football players you're actually selecting. So those are some things to think about. An airline that claims 85% of its flights arrive in Denver on time or early. Today, 110 planes will arrive in Denver at random. A sample of 15 of these planes is selected. What is the probability that more than 80% will be on time or early? So you might get sucked into trying to do this problem, but you would find that if you find out that it was normal, 15 times 0.85 might be right around 10, but 15 times 0.15 is just a little bit more than 2, so it's not a normal distribution. Okay, because the probability that it can times your sample and the probability that it can't times your samples both have to be larger than 10 as a general rule. Number 2, it is assumed that 25% of college students wear contacts. We randomly pick 150 students at a university. What is the standard error? Well, the standard error is the square root of 0.25 times 0.75 divided by 150. So 0.25 times 0.75 over 250. Let's see.
Do you mean 150?
Huh? 150, right?
You said 250.
I'm sorry. I can't read my own writing. All right, so if you do that, then you're going to get your standard error. So remember that standard error starts dealing with, slices. So think about the large slice of bread that I'd like to take when I get home, but then think about what actually probably should be taken. Do the 3 assumptions apply random? Says we randomly pick, so yes, it's random. Normal is a normal distribution. Well, 150 times 0.25 and 150 times 0.75. Both of those will be bigger than 10, so yes, it should be normal. Is it independent? Do you think 150 is less than 10% of all college students? I think so, so it should be an independent routine. What is the probability that fewer than 30 of the selected students wear contacts? So remember, if you're talking this, you're talking fewer, this is the part of the area that you're looking for. So NCDF, negative 1,000 or negative 10,000 or whatever. 30 out of the 150 is the probability times 0.25 times the square root of 0.25 times 0.75. Get in there. All over 150 of your sample. That should give you your NCDF. And again, remember, make sure your square root's going all over the whole thing. What is the probability that more than 45 of the selected students wear contacts? So remember, the more than 45, you're looking at this region. So it's going to be the NCDF. Oh, I just picked something that was way down low. Could have been negative 100. It probably even could have been 0. Just negative 1,000 is way this way. But this number, I mean, just make sure that number is at least 4 standard deviations below. And so if you just pick a arbitrary big number, that's perfect. That's far enough away. Letter D, NCDF. So 45 out of the 150. I like it. Comma. Where you need to pick a number more than a couple standard deviations away, so we can pick 1,000, I guess. 0.25 is the same. And then the 0.25, 0.75 over 150 root of that. And then what's the difference? So C and D, I had a way far left limit. D, I had a way far right limit for my upper and lower bounds. But what about letter E? What's my lower bound on letter E? Yeah, so NCDF. So my lower bound is 40 out of 150. My upper bound is 55 out of 150. And then my 0.25 and my root 0.25 times 0.75 over 150 would give you that. So this is just a small cross-section area of the area underneath the curve. God bless you. Making okay sense? Yeah. C and D as E's answer? It might be just coincidental. You want me to work it real quick on the calculator? Yeah, absolutely. So C and D, you want the answers worked out? All right. All right. So letter C, we're going to go second, bars, NCDF. And then I'm going to do like negative 1,000, negative 100 for lower. Comma, let's see. I have 30 out of 150. 30 divided by 150. Comma. 0.25. Comma. And then I have to probably put a couple parentheses in. So I have this. I'm going to do parentheses, 0.25 times 0.75. Close, divided by 150. Close parentheses. Please note that you can see that this root sign is continuing. Hit enter. Is that what you got? Okay. So that's for letter C. Letter D, this might be just coincidental that it happened. So I'm just going to go second entry. Because I know that that's going to be the same, so I don't have to enter the whole thing in again. Oops. Over. 45 divided by 150. Oh, thank you. Bless you. I have 1,500, comma, and then like 1,000 or whatever. See what number I have here. I think it's just coincidental that it's the exact same answer. I mean, it's the same answer because the area to the left is the same as the area to the right. Hello, Miss Cooper. What's up?
For third period.
Sure. Oh, third, I have a meeting real quick for about 15 minutes.
I cover for 15.
I'll be back because I'm going to meet with the PTCO at the night class for a few minutes.
All right.
But I'll be in and out as fast as I can.
Okay, so if Joelle like do the first 15 minutes, then I mean tell her you'll be back.
Yeah, which room number would you like in?
So that would be there. It's all down.
Algebra straight upstairs. 344. 434. 434. Got it.
Sorry, guys.
You're okay. All right. Does anyone need me to do E or are we okay? All right. Okay, number 3, Summit County records show snowfall each year. Over the years, it has become discovered that the total snowfall is normal, mean 270, standard deviation 15. What's the probability next year is no more than 280 inches? So NCDF 280, comma 1,000.
Wait,
comma,
I put that in my calculator, like D in my calculator, and it didn't work. It said error syntax.
on the last problem?
Yeah.
Really? Okay, hang on, let's take a look.
I don't know what I did wrong.
For letter D, the one I just worked.
Yeah, I just put it in my calculator and it's just not working.
Okay, here, I'll do it longhand again. Second bars, normal CDF. Is your calculator taking it in like this, or is it taking it in where you go down the columns?
You go down the columns.
Okay, let me come to you.
Alright. Like, yeah.
Like, yeah. This one might not allow that. So, let's just solve it. So just solve it. there was some sort of something that was in one of the screens that. So the second memory reset kind of just puts all of it.
Awesome, thank you.
You got it. All right, are we okay with number 3, or do you need me to do anything with that? Do what?
How do you do the years for numbers for letter C? Sorry.
Letter C. I randomly picked 3 years. So on that one, let me close this up. Shh. On the years. Letter C on that one, you're going to do the NCDF, and you have 280, like 1,000 would be fine probably, and 270, and then you're going to go 15 over the square root of 3, because it's 3 years. Yeah,
Oh. On A and B, what's your fourth stop?
15 and 15 on both, because you're talking about just 1 year. Yeah, so on A and B, this is going to be the square root of 1 on A and B, which is the same thing as 15 over 1, which is 15. And then D, is everyone okay? And then on E, the only thing that's different on letter E is this whole thing is the same, except you have 15 over the square root of 10, because you're talking 10 years. Okay, everyone feel okay with these? Is there any others you need me to work out? You.
For C on 4.
C4.
I don't know how. I just keep. Would you do 60 over 40?
I haven't worked this one out yet, so let me just work it out.
Okay.
The bank believes that 14.5% of people who receive loans will have a late. So average is 14.5. And based on the past experience, bank believes 14.5% people who receive loans will have a late payment at some point during the loan period. Bank approved 400 loans. I don't think you could do number 4
Yeah, I keep getting
because
0.
you don't have a standard deviation at all.
I thought 14.5 was a standard. No, that's an average.
That's an average.
Okay, that's where I was getting really confused. I'm like, wait, that's the average. So you can't do it at all.
Yeah, this one's not going to work because we don't have. We don't have a standard deviation, so I don't think we could do it.
Okay.
We did where?
But you don't always have standard deviation like 2.
Okay.
So you can.
Okay, we can. All right. So 3 assumptions apply. Random, yes. 400
No,
people.
the assumptions are wrong because it's 400 times 1.1, and it's less than 10.
That's less than 10. 400 times 0.145.
Yeah, it's 5.8. No, did I do that wrong?
Yeah. That should work there.
Oh,
And
I don't know
400
where-
loans
I
should
got
be less than 10% of all loans. So I like it.
Okay, never mind. Sorry.
Oh, so this is, we have to find the standard error for this. So the standard error is going to be 0.145 times 0.855. Thank you. All over what? 400. So that'll be the standard deviation. That will use that for the standard error.
That's your standard error?
Yeah, which will be the standard deviation. And then what is the probability that more than 60 people are late on their payment? So you're talking like this kind of area. So you have an NCDF, and so you have 60 out of 400, comma, like 2,000 sounds good, upper limit, or 1,000, whatever. And then we're going to have our standard error, or we're going to have the 0.145, and then we're going to have times that. And that would be more than 60. What is the probability that fewer than 40? So the second one, fewer than 40, so like negative 100, and then 40 out of 400. 0.145, and that same thing. That should be both C and D's answers. And then E's answer, you're going to have for your lower limit 35 out of 400 and 55 out of 400 with 0.145 and that again.
You're doing 0 because that's your standard error.
I'm not doing 0. I just didn't want to rewrite that.
Wait, but whenever you use what you got, would you never use your standard deviation then in those problems? Because I thought you did. Oh, that's
So-
what that square root is. Never mind, sorry.
Standard errors. And then what is the z-score for 42 people being late? So remember the z-score is observed. Z equals observed minus the mean over the standard deviation. So you'd have to have this here, and you're looking for your observed, finding your z-score, the one they give you. Or so it's going to be 42 minus 400. What was it? 400 over this whole thing, and that'll give you a z-score. Are we okay? So the big thing you know you're going to see is, do the 3 assumptions work? Okay? Is it random? How do you know if it's random? How do you know if a problem's random? It tells us. You have to trust. If it says, hey, we randomly selected, you have to trust that they're telling the truth. Okay? So that's the first thing you're looking for. So you're just looking for the word randomly or random or a random sample. And then to check if it's normal, a normal distribution. How do we do a normal distribution? What was that?
Isn't that where you do like what all you have times 10%? Or if it's 10 more than what?
Yeah, so this is P times the N and Q times the N. Both of those values have to be greater than 10.
What's your
If that takes place, then we're good.
what's
N
That's
is like our whole population.
Oh, sorry, I was talking about independence.
And then independent is, are we less than 10% of the entire population that we were talking about? So if you were talking about like M&Ms, there are billions of M&Ms made each year, right? So it's pretty easy if we take a sample that we're going to be less than 10%, unless you're like 500 trillion M&Ms we're testing. Okay, that's a lot of M&Ms. So I think if you feel good about 6.3, if you guys totally insist you want to do 6.4, go for it, but I don't know if you necessarily need it. And we will quiz or test tomorrow. Sound good?